Hello students, today I am starting in this video. I am explaining you the topic integration by parts. When u and v are two different functions, different type of functions, then the integration of their product is u is the first function here and v is the second function. So it is u integration of v dx minus integration of this part, that is d by dx of u integration of v dx whole dx. Now in this, when we take any problem and we start with integration by parts, the biggest problem comes to select the first function and second function. Like if there is a problem x sin x. Yes. Now there are two different functions. One is the algebraic function and the second is trigonometrical function. So out of these two functions, which function is to be taken as u and which function is to be taken as v, or the function which is written first will be u and the second will be v? What is the criteria for? So here you see this term, this word here, islet. I stands for inverse, L for logarithm, A for algebra, T for trigonometry, and E for exponential. So now, in this order, whatever comes first, that will be the U, and whatever is coming second, that will be the V. Now here it is algebra and trigonometry. Algebra and trigonometry. So we have to take this U as x as u and sine as v. That is the important criteria in selecting the u and v. And now we can apply the formula. It is x integration of sine x dx minus d by dx of x integration of sine x dx whole dx. Please see the step. You know the integration of sine x is minus cos x. So minus x cos x minus integration d by dx of x is 1 and it is minus cos x dx. This part is minus cos x. So the next part is x cos x. This minus and minus plus, and the integration of cos x is sin x plus c. So that is the integration by parts. Here it is totally a formula based problem. The success of this depend on the proper selection of the first function as well as second function. Means how you are selecting the first function and second function. I am taking one more problem. Please see in this connection. The problem is x square e power x dx. See this problem. Here algebra and exponential. Algebra and exponential. So this is to be taken as u and this is to be taken as v. Now you see it is x square integration of e power x minus d by dx of x square integration of e power x dx whole dx. So the answer is x square e power x minus d by dx of x square is 2x and e power x and then whole dx. This part is e power x. Now see this step. Again we have to go for the integration by parts. So this part will remain as it is, minus 2 and x integration of e power x dx minus d by dx of x dot integration of e power x dx whole dx and then bracket. So you see the step now, x square e power x minus 2 x e power x. This x and this is e power x minus, you see this now, this is 1 and e power x is e power x plus dx. So the last step is x square e power x, this one, minus 2x e power x, this minus and minus plus 2 e power x plus c. So in this way we can find the integration by the parts. I am taking some more type of sum in this category. See the next problem now. Yes, see this problem, x log x. Now in this, according to the islet, the log comes first. So this we will take as u and this we will take as v. So it is log x integration of x dx minus d by dx of d by dx of log x integration of x dx whole dx. Please see this now. It is not that the function which is coming first we have to take as u and the second as v. We have to consider this islet. It is I must say a trick which is helping a lot in the integration by parts when we have two different type of function. See, this is algebraic function and this is logarithmic function. So next part is log x, integration of x is x square by 2, d by dx of log x is 1 by x and it is x square by 2 dx. So the next part is x square by 2 log x minus 1 by 2 here and it is x dx. So the final answer is x square by 2 log x minus 1 by 2 x square by 2 plus c. So in this way we can integrate this particular function by integration by the parts. I am taking the next type of function. I am including all the type of sum. See the next type now. Yes, this time I have taken now algebra and inverse. So inverse trigonometry and algebra. So we have to take this as first function and this as second function. This is one method. The second method is we can apply the substitution method and sine inverse x we can take as t. Then x will be sine t and dx will be cos t dt. So this problem will take the form x will be sine t and sine inverse t will be t and this will be cos t dt. And if I multiply and divide it by 2, then it is half t sine 2t dt. Please see this part now. t sine 2t dt. And here, now this is algebra and this is inverse. So it can be, we can solve it by the integration by parts, where t will be the first function and sine 2t dt minus integration d by dt of t integration of sine 2t dt and whole dt and the bracket close. So here it is 1 by 2 t minus cos 2t upon 2. That is the integration of sine 2t minus integration of d by dt of t is 1 and this will be minus cos 2t divided by 2 dt. So the next part is minus, multiply this, it is 1 by 4 t cos 2t minus, and it will be plus now because of this minus and half it will be 1 by 4 cos 2t dt. So final answer is 1 by 4 cos 2t plus 1 by 4 sine 2t divided by 2 plus c, and again we can put the value of t as sine inverse x and you will get, so here the t is sine inverse x and accordingly you can complete your sum. So in this way we can take, this is one method. The second method is you can take sine inverse x as t and this x as sine inverse x as the first function and x as the second function. So that method also can be applied in this particular sum. So this is regarding the algebra as well as inverse. I am taking the next type of sum. Yes, now you see the next problem. In this, as we have done just now, x cos inverse x sin inverse x, and we have used a strategy there. But if you see this part, it is x cos inverse x and root 1 minus x square. Now see, this something related to the derivative of cos inverse x is given here. So we can apply the substitution method as well as the integration by parts. And here, if we take cos inverse x as t minus 1 upon 1 minus x square dx as dt. You see, it is ready here. And by this, the value of x will be cos t also. So this sum will take the form, the x will be cos t and this will be t. So the form will be t cos t dt. And because of this minus, it will be minus here. So minus t cos t. And now it becomes very simple. So substitution method is having its own importance throughout the integration. Here minus, now we'll apply, taking this as the first function and this is the second function. So t cos t dt minus d by dt of t integration of cos t dt whole dt. So minus t sin t minus d by dt of t is 1 and cos t is sin t dt. Next part, minus t sin t minus cos t. And you know sin t is minus cos t, so it will be plus c. And in this now, we can put the value of t as cos inverse x, and that will be the final part of this sum. So I hope you understood that always whenever it is cos inverse, it is not that all the time we write dx equals to minus cos t dt. We have to see the problem and accordingly we have to make our strategy. That is the important part in the integration by parts. Different sum, the different strategy will be there. Yes, dear student, you see, it is tan inverse t and no second function. So in these type of functions, when there is a logarithmic function and inverse function and the second function is not given, then we take this as first function and we take 1 as a second function. That is one method. And the second method is we can apply the substitution method. Like tan inverse x, I can take t. So x will be tan t dt, tan t. So the derivative will be dx equals to sec square t dt. Now we convert this sum. So it will take the form t sec square t dt. This will be t and dx will be sec square t dt. And now easily we can apply the integration by parts, that is Euler rule, taking this as u and this as v. So it is t sec square t dt minus d by dt of t integration of sec square t dt whole dt. So the answer is t sec square t, the integration is tan t minus d by dx of t, d by dt of t is 1 and this is tan t dt. So the final answer is t tan t minus, you know the integration of tan x is log, please see this part, the integration of tan x is log sec x. So here I can write log sec x. So sec t plus c, and again we can put the value of t here. So that will be the final answer. So I hope this part is clear to you, that if it is only one function, logarithmic or it is inverse trigonometrical, we can apply this method, or as I told you, we can take one unity as a second function and then we can proceed for this particular part. So I hope this part is clear to you. Next problem.